group is to implement eigenface calculator. So the first is what is eigenface. Eigenface is commonly used in many fields, and when you want to implement the face recognition, the first step is to calculate the eigenface. And the eigenface is basically to reconstruct a facial image. So each image can be represented with different eigenface. Our project uses a dataset named Jeffy. In the dataset, it contains 216 images with 7 expressions. Each image, the size is 256 multiple 256, so each image can be considered as a matrix. So our project is focused on the computation of matrix and the algorithm of it.
So to calculate the eigenface, we use an algorithm called principal component analysis, that is PCA. So PCA can help reduce the dimensions of the image matrix. For example, we can see like n by n image here. So in our case, it's 256 by 256 image. We will convert this image into a n square column vector. So we have totally m. So here m is 230 image. We have m, a big matrix. We will calculate this. We will calculate this n squared by n squared matrix eigenvalues and eigenvectors. So to calculate this, it is a very large matrix. It's impossible. So we will convert it to a smaller matrix that is m by n. So by computing this, we will keep only k eigenvectors after the result, after we get the result. Here is the result, and this is the top 8 eigenfaces. So this is the top 1 and top 2, such as this, and this is the main eigenface. So the eigenface looks like a ghost, but actually it shows out the, for example, eyes, nose, mouth, despite the expressions in the original face. So it eliminates all the expressions. It only kept the eyes, nose, mouth, such obvious characteristics. So it will. So this is the main goal of the eigenfaces. Let's see. So now here there is also 6 eigenfaces. This eigenfaces is almost the last several. So you can see, compared to the previous slide, the eigenfaces is not very clear to see. It's only have a little image, a little information about the face. It's like the edge of the face. So we cannot see much information about that. So in the reconstruction of our face, these eigenfaces will be left out. We will not use these faces. Here is the reconstruction of one image. So this one is the one very similar to the original one. So this is the main face. We use 8 eigenfaces, these 8 eigenfaces, to add on, to add on, and then we got the reconstruction of the image. And here is a piece of the code of. And we also go a little further. So that is, we did a simple face recognition. Given a test face image, so we will let the system check whether the test image is in the dataset or not. So if the test image, such as this image, is in the dataset, it will recognize that it is the 23rd face. And if the test image is not in the dataset, such as the eigenface here, it will show out that there is no face match. And this is the relevant code.
We built a simple web application to help the users to run the code. So you can see the pictures. We can see the simple demo. This is the index, and when the users want to calculate, he can click the calculate button. So it can return the pictures of the result. In that case, we just return the average face of the data set. And if you want to download the file, you can click this button. And at present, our project just focus on the existing data set. So in the future, we plan to make possible for the users that they can upload their own pictures and calculate their own eigenface. This is the next step we will do.
Hello everyone. Our project is to do an eigenface calculator. Eigenface is very important in face recognition, and we will do this first step in our project. So let's start. This is our dataset called Jeffy. We will use it in our project. So first, I will upload the third image in our project, in our platform. So this is our platform called Jupyter, and here is our test folder. I have already uploaded the third image, and then we can start to calculate the eigenfaces of all the 230 images. So let's run this. So this is the mean eigenface of the 230 image, and then this is top 10, the first, second, blah 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 blah. So this eigenfaces look like a ghost, but it will show all the eyes, nose, and mouth. You can see these eyes, elbows are very clear, although the hair or the expressions are eliminated, but it's very clear in other characters. And the input and output shows that our input test face is recognized as face 3. That's correct because in our dataset it's actually the third image. And we also test this in our MATLAB. This is our MATLAB code. We have already tested it. So let's start. Yes, this is all the 25 eigenfaces, and you can see you can see the eigenfaces is as same as the one calculated here. So that's correct for our code.
Also implement a simple web application to help users easily run the code. So this is our web application. You can see the index. And when the users want to calculate, he can click the calculate button. So it can return the result of the computation. In that case, we just return the average face of the data set. And in the future, we plan to improve our application so that the users can upload his own pictures and compute the eigenface of his own pictures. Also, if you want to download the result, you can click this button so it can download. That's okay.